Greetings, chemistry students. Today we're going to learn how to do ionic compound formulas from names with transition metals. This is taking this one step further. Let's review. The transition metals are in groups 3 through 12 on the periodic table. These are the things that we in everyday life consider to be metals. This is what we've had a lot of experience with things like gold, silver, copper, nickel, cobalt, iron. So these are all the things when we think of metals come to our mind. These are what we're thinking about. So we're going to learn how to do formulas for names with these. So the big thing is these, because of that d block orbitals they can have variable valence electrons. Their oxidation numbers can change. And so the formula has to give it to you. This has to be given. There's no way for us knowing. It's very difficult to determine and can only be determined in a lab. It all depends on temperature, pressure, condition, all that kind of stuff. So we use the oxidation number given in the name. This is iron 2 oxide, and that 2 tells you the oxidation number, how the metal in this particular compound combined with this nonmetal, the cation and the anion. So with that 2, we just set it up like normal, write down the names of the elements, Fe, and it has that 2 and the oxygen O. We do the swap, and then we do the drop. We check for lowest ratio. We don't have the lowest ratio, and then we reduce it to FeO. Here's another example. Lead 2 sulfate, lead 4 sulfate, excuse me. So we have the Roman numeral 4, so that is the oxidation number. That doesn't tell us how many leads there are, that tells us how that lead combined. It's the oxidation number. So we write down both elements with their oxidation numbers. We do the swap, and then we do the drop, and then we check for the lowest ratio. Is this the lowest ratio? Doesn't look like it. Nope. We can reduce that to PbS2. This is lead sulfide. Some exceptions to the transition metal rules. These are because zinc and silver always combine the same way, you don't have to write down the Roman numeral. I would write this right on your reference table above the transition metals that these are exceptions, silver and zinc. You don't have to write the Roman numeral at them. No Roman numeral needed. So let's look at how to do this when you have a polyatomic ion. This is pretty easy, but just happens to scare people. So let's say we had copper 1 carbonate. Well, we would start by writing down both the anion and the cation and the anion. The copper 1, this is the biggest mistake I see. People see that 1 and they think it means there's one copper atom in this compound. No, this 1 tells us how the copper bonded. It is the oxidation number. So what you need to do is Cu plus 1. The carbonate, we find the carbonate right on our polyatomic ion list on page 7 of our reference table. And then we do the swap, and then the drop. After we do the swap and drop, we check it, make sure it's the lowest ratio, and then we check to make sure that we did not use the 1 as the subscript. The 1 here in copper 1 carbonate is the oxidation number. It is how the copper will bond. So today we learned how to take the name of a compound with a transition metal, read the oxidation number of that transition metal, do our swap and drop just like normal. The only difference is we have to make sure we realize that the Roman numeral is the oxidation number for our transition metal, not the subscript. Have a great day.